Sometimes when we're looking at growth models, there's a limit to that growth. It just can't continue to go up forever. And one of the areas that we may see this is in the area of population, where maybe space or food or water, or there's some type of limiting factor to a growth. And we can model that with a logistic regression. Now, the formula for logistic regression would be, let's say, f of, f of x, we'll call it, is equal to c, and c is where is the limit of the growth. C over 1 plus a times the natural base raised to the value, raise an exponential, raise it to the exponent of negative b of x. Okay, where a, b, and c are positive exponents. Now we're going to look at some data here that would lend itself towards this logistic regression. So it says use a logistic regression to model the data in the table about a lake's fish population. Well, if you think about it, the population of fish in a lake is going to have some type of limit to it just based on the space and the water, and there could be other things too, the structure in the lake, the food supply in the lake. There could be any number of things that could limit the population. In other words, population can't grow just exponentially out forever. Sooner or later, there's going to be a limit. So we have a table here of data where we've got time in terms of months going from 0 out to 24 months. And then we have some data regarding the fish population in this lake over these periods of months. And of course, we're headed to the calculator. We're going to input our data. And then we are going to use a logistic regression. Now, we've used exponential, we've used logarithmic. Now we're going to use a logistic regression, which makes the assumption that there's a limit to the growth that can occur in this situation. So let's move over to the calculator and we shall get on with it. Here we are. I've already checked to make sure my stat plot was turned on. I'll make sure that I'm using the scatter plot feature as far as the type of presentation that I want to see. And I've already entered the data that was in the table. So in L1, this is in a number of months going from 0 out to 24. And in L2 is the fish population at the end of those particular months. So I want to get a logistics equation, so I'm going to go to stat, and I'm going to go to calc, and I'm just going to scroll down here, and I believe it's option B actually. Yes, I see there in option B, I see logistics. So this is going to give me a logistic regression equation. So I'm going to choose that, I'm going to hit enter, and we're just going to enter our way through this. And it takes a moment for this to come up. It's doing a lot of calculating. Okay, there we go. So we got an equation where y equals c, where c is equal to 8498.857, whatever. Let's see if we rounded that to the nearest hundredth, it'd be 8498.86. And then that is divided by or over 1 plus a, 64.70, if we rounded that, times the natural base e raised to the power of negative b, 0.39x. Now I want to put this equation into y equals, so I'm going to go into y equals. Well, I'll tell you what, before I do that though, let's just take a look and see what our data looks like. I'm going to hit zoom, option 9, stat. Let's just see, okay. And I can see here that it's going up, 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 and then it begins to level off. And this would be characteristic of a logistic regression. Now let's enter that into our y equals. Go back to do that. I got y equals. I'm going to hit vars. This should become familiar with you now because we've done it often. Option 5, statistics. I'm going to EQ. equation. I'm going to choose that regression equation, that logistic regression equation. And I can see part of it as it's listed here, but it inserted that entire regression equation. And now let's look at the graph. And I can see it pretty much ties straight in. It's tied there. Now, the second part of this was to predict about where the limit to the growth comes from. And maybe the best place to see that is in the table. Now, remember, we went out to 24 months. I'm just going to kind of scroll down here. I could hit value, I suppose, but we're going to just scroll down here. And there at 24 months, I got 8451.3. Remember, our data was 8450, 8,450. But if I continue scrolling, and if you just kind of follow along, I'm getting closer and closer to 8,500. But I'm already out here now at 38 months, 40. Let's just double it out to 48. At 48 months, I'm seeing 8,498.9. You can see I'm getting really close to 8,500, but I'm not hitting 8,500. I'm not going above 8,500. And so then I would say that the limit to growth of the fish population in this particular lake would be about 8,500 fish. Now, you need to go fishing. I used to go fishing a lot. Fishing is fun. And if there's 8,500 fish in the lake, we need to take some out. Eat fish.